Welcome to another episode of A Day in the Life of an Incident Responder. In this episode, I will be going over how to monitor and detect lists of basic data objects. If you are like me, you work for an organization that gets intel feeds from computer emergency response teams in the form of MD5, SHA hashes, and file names. It is my responsibility then to see if our enterprise is affected by these hashes or names. In this demo, I will show you how to take a list of MD5 hashes, import them into CloudHash, and monitor for them on a scheduled basis. So before we get into the demo, let's do a refresher on how CloudHash functions and its architecture. CloudHash is a distributed network of client-based journals which enable you to query them from a central location. It runs as a service on the local systems and records all changes being made to the file system in an index on that computer. This journal can then be searched from the remote server using policy-based signatures, which are monitored in real time, or through scheduled tasks. Also, with our McAfee DXL integration, you can also search these journals instantly. So, when a new process starts, the CloudHash system will journal that file. When a file is downloaded from the internet, CloudHash journals that change, or when an email is opened, CloudHash will journal that new file. If you were to change a document, that change would also be updated in the journal. With this type of architecture, you get several advantages. First, you don't need a massive server to hold indexable file metadata. Just use the power of your existing enterprise. Second, you don't have to perform scans anymore to find these known bad MD5 signatures. Just create the task and policy and you'll be notified when it's found. Third, because it's journaled locally, you get the advantage of historical data. As most are aware, intel reports are always late, so typically by the time you search for these items, the files are long gone and the compromise will go unnoticed because these files have been cleaned up. As I stated before, CloudHash is distributed. Communication with the endpoints happens in multiple forms, either through policy, scheduled task, or threat event data, and if you have DXL in your enterprise, instantly through the DXL fabric. So now you have a basic understanding of the architecture of CloudHash. Let's dive into the demo. So the first thing we do is browse to our files, your system tree, and go to the Assign Client Tasks tab. From there, we will create a new task, schedule that task, and then assign it to our entire enterprise. So as you can see, we are already in the Assign Client Task tab. So the first thing we need to do is choose a new client task assignment through our actions. So from here, we will choose the product CloudHash Security 1.5. We will then choose the type of basic query. So the basic query tasks are simply a very simple list of MD5 hashes, SHA-1 hashes, file names, or fuzzy hashes that has been separated with an OR condition. So let's go ahead and click Create New Task. So as you can see here, we have all four of our types. From here, we can actually import a list of MD5 hashes. So that's what I'm going to do now. I'm going to come down here. I'm going to hit Import File. I will then browse to an MD5 list that I've gotten from a higher echelon cert. The upload type is going to be MD5 hashes, and that this file is separated by line breaks. I click OK. The import is completed, and all my MD5 hashes are now in my task. I'll now give my task a very simple name and click Save. So the next step in this here is actually choose our task, which is already chosen for us, and click Next. Here we can schedule our task to run daily. We can have it run weekly, monthly, and then we can have it run at login and other choices. But for this first one, what we're going to want to do is have it run immediately so we can see if it's on our network right now. We can go back through and through a secondary task, schedule this thing to run on a daily schedule. I click Save. It then applies to my entire organization, and now I can actually wake up my clients and get that task to run. So what I'm going to do now is actually go into my lab and wake up one of my agents. So now we send events back up to the server. We're going to go ahead and view those events coming back from our client task. So we'll go into our menu, we'll go into our thread event log inside of EPO and wait for the events to come in. So here you see we have 3 events come in, all with the same threat name because there was 3 MD5 hashes that triggered at the endpoint. So the first thing I want to do is actually add some columns into this view just to get a quick look on what actually was reported. So if I choose columns, I want to go ahead and add the file name in the directory where it triggered. You'll save those columns. As you can see, we have the 2 new columns added here. It looks like we have a couple MD5 hashes that are known good, so we'll have to go ahead and update our task to remove those items. But this first one here actually looks like it's something bad, so let's go ahead and drill down into this event. So here you see all the standard thread event log data that EPO normally provides. At the very bottom is the additional Cloud Hash security event info with all the metadata surrounding that file that triggered. So if we click more, we actually get to see all the metadata on that file. Here you see we provide you with the last seen date. That's the last time Cloud Hash saw it. You see that we have an inserted on, which this is the date that it was actually first seen by Cloud Hash. The last time the file was accessed according to Windows, the full path, when it was created on the file system, if it has a certificate, if it's been deleted on the system, if it's still present on the system. You see we provide you with the SHA-1 and the file size in bytes. You see there's also a directory here, the last time the file was updated, the last time the file was compiled, and the MD5 hash of that file. The is historical, because we are storing modifications of files. This will tell you if it's a historical version of this file or if it's a current version of this file. Finally, I want to highlight this last piece here, which is this fuzzy hash. So the unique thing that Cloud Hash brings you is that fuzzy hash. It gives you the ability to do percent-based matches on files. So for instance, a MD5 or SHA-1 hash is a 1-to-1 ratio. So to give you an example, if I was to have the MD5 hash of a Word document, the moment a user changed a letter in that document and saved it, the MD5 and SHA-1 hashes changed completely. But the fuzzy hash only changes slightly, which now gives me allowance to do percent-based matches on that MD or that fuzzy hash. And now you don't have to know exactly what the files are. You can just see what's actually similar to these files. From here we can actually create signatures or add them to HIPS application groups. Those are all 4 different videos. So from here I will end the episode. Go ahead and check back at a later time for more videos, and thank you very much for watching.